All right, guys. So I think all of
Sorry, special happy birthday to Lily Egg. Thank you and have a great day.
well, so yesterday y'all went on and watched the video. I believe all of y'all did. I've thumbed through them. You did all of them. I think most of y'all noticed the goof or error on 18. Yep. Yep. Yeah, because I think it was just I rewrote, or when I multiplied, I wrote the wrong 2, or the second one down wrong, which messed up the rest of it. But the idea is still the same. Y'all got those done. So again, that is an assignment. I'm making that a 40-point assignment. Since y'all did it all, you got all 40 points. Now, if you missed one, that's why I'm giving you back. It's going to be all or nothing. So you either did all of them and got all the points, or you didn't do all of them and you get none of the points. Mainly because it is a video. You just have to watch it and follow along. So we have that. Now today, we're working on multiplication, division, and complex fractions. So we're going through this here today. We'll finish it up tomorrow. Now multiplying two fractions, the first thing we need to do is factor each of the numerators and each of the denominators completely, then multiply them together. Now if we look at this one here, 3x squared, 4y cubed, the two numerators are as simplified as they get. They're a single term. There's nothing we can do with them. There's no way to simplify them. 2y and 3x are already as simple as they get. So we can just multiply these together. So we can multiply the numerators. We can say 3 times 4 is x squared is the only x term on top, so it just says x squared. Y to the third is the only y term in the numerators or on top. So it says y to the third. We can multiply the denominators. 2 times 3 is xy. Now at this point here, we can simplify because 12 over 6 is going to reduce to almost 2 over 1. Yes. Now we do need to reduce the x over x squared. Whenever we divide like bases, we subtract the exponents. X, and it's on top because 2 minus 1 is 1. Since it's bigger on top, it stays on top. The same thing is true with y to the third over y. 3 minus 1 is 2. And since it's bigger on top, it stays on top. So we get this here. Or we could say this is the same as just 2xy squared. Because the division of 1 or having 1 in the denominator, we don't have to write it back in. We can leave it as this here. Yes. Yes. So, questions on this one here? We good with this problem here? Let's look at the next one. Multiply x minus 5 by 7 over x cubed minus 5x squared. Well, the x minus 5's denominator is 1. Now, whenever we multiply, we do want to factor each of the numerators and denominators completely. This is different than addition and subtraction. When we added or subtracted, we only factored the denominators, got them to be the same, and then simplify from there. With multiplication, we want to simplify everything completely at the start. Now, x minus 5 is as factored and simplified as possible. We can't simplify it any further. However, the x cubed minus 5x squared is factorable. It has a greatest common factor of x squared that we can factor out of both terms. And if we factor an x squared out of x cubed, we're left with x. And then x squared out of 5x squared was left with 5. They will. Now, we can multiply these together. Now, when we multiply straight across, we don't want to distribute. And what I mean by that is multiplying the 7 times x and the 7 times negative 5. We could, but that would give us 7x minus 35. But for us to be able to simplify top and bottom, we need it factored, which means I'd have to factor the 7 back out, get back to this here, which is just easier to say this. 7 times x minus 5 over x squared times x minus 5. Because when we multiply x squared times x minus 5 by 1, we just get x squared times x minus 5. And yes, indeed, as y'all were saying earlier, those will cancel, leaving us with just 7 over x squared. Realistically, we could have connected them here and said they were, y'all know, would have given us the same answer. Questions on any of this here? Now looking at this one here, the 3x and 6x squared are as simplified as they get. One of the kind of giveaways is that they are monomials, they're single terms. There's nothing we can do to them. We don't have the addition or subtraction. Now the x plus 2 squared is as simplified as it gets. We can leave it as x plus 2 squared, or we can rewrite it out as x plus 2 times x plus 2. They're the same thing. Because x plus 2 squared is just saying that x plus 2 is being multiplied by itself. So we have two of them. Now the only one we might, or actually need to factor, is x squared minus 4, which is x plus 2 and x minus 2. It is a difference of perfect squares. Because whenever we have two terms being subtracted, we can look for a greatest common factor first. But x squared and 4 do not have a greatest common factor. X squared is a perfect square. It's x and x. 4 is 2 and 2. So we have x plus 2 and... Yep. Now if we wanted to, we could connect these and simplify the x plus 2's. Or if we wanted to, we can move the monomials. Our greatest common factors are individual terms out front, and multiplying with our sets of parentheses, x plus 2 and x plus 2. We have x plus 2 and x minus 2 on bottom. Now when it comes to simplifying, really, when we simplify our sets of parentheses, I think those are the easiest to simplify because it's really just matching them on top and bottom. I have an x plus 2 on bottom, that matches up with 1x plus 2 on top. And really that's all that simplifies on top and bottom with our sets of parentheses, yes? So we know that we will still have an x plus 2 in the numerator and an x minus 2 in the denominator. They will stay. Now we need to simplify our other two terms, 3x and 6x squared. Well, 3 over 6 will reduce to what? Right, 1/2, 1 over 2. We can just leave it as 2 on bottom. We can write 1 over 2 either way. X over x squared. Yes, we would simplify 1 on top and bottom. Or we can subtract the exponents. 2 minus 1 is 1. Is it bigger on top or bottom? So we get this here. So we have 1 times x plus 2 over 2x times x minus 2. Now we could rewrite this and make it look a little bit nicer as x plus 2 over 2x times x minus 2, but either one of these is correct. Either one of these two is the correct answer. I think the one on the right looks a little bit nicer, a little bit neater, because we don't necessarily need the 1, or as I have it, that kind of awkward little space in between them. We can write it as either one of these here. They're both the correct answer. Questions on these here? Now looking at this here, are there any that don't or are not factorable? Yeah. 2x minus 1 is not factorable because 2x and 1 do not have a greatest common factor. The degree with x is 1. That's as simplified as it gets. How about 3x plus 2? Is there a greatest common factor between 3 and 2? What's the power with x? So that there is as simplified as it gets. If we don't have an x squared, x cubed, x to a power greater than 1, we're really just looking for greatest common factor. And that's really what we should start out with most of these here, which means 3x plus 2 over here is simplified. Now, the last one we have left is negative 4 plus 8x. Does it have a greatest common factor? 4. Now I'm going to rewrite it so that we have x first, as if we divide 4 out of 8x, 8 divided by 4 is x minus 1. So we multiply them together. The 2x minus the 1's will cancel out. The 3x plus 2's will, leaving us with 4 over 1 or 4. Either of these is the correct answer. Now, if the 4 had been on bottom, we would have to leave it as 1/4, because 1/4 and 4 are not the same. But 4 divided by 1 and 4 are. Questions on this here? You ready for the next one? Now, this one here is a little bit more complicated than the two we had previous. Would we agree with that? Now, we have 4 different places where we can factor, because the 2 numerators will factor, the 2 denominators will factor. And looking at these 4, which one of these 4 do you think is going to be the easiest to factor? Yes, the x squared plus 6x plus 5. We'd agree with that there, yes? Now, again, first thing I would look at any of them is for greatest common factor. But since x squared, there's not a number in front of it, we won't factor out a number, and since 5 doesn't have an x, there is no greatest common factor. So we have our 2 sets of parentheses with 3 spaces. Now we look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here it's positive, so they're the same and match the sign of the middle term. We have plus and plus. Exactly. Factors of our first term would be x and x. 1 and 5 would be our factors of the third term. And if we did check this, we would indeed get 6x. Now, again, I've said this, I think, well, I most likely have said this before. The reason we start with the one that we can find the factors easiest is because if something's going to simplify, one of the numerators has to factor to what? X plus 1 or x plus 5. It gives us a hint at what one of the numerators factors should be. Where do we want to go to next? 2x squared plus x minus 1. Well, there's not a greatest common factor, so we have 2 sets of parentheses. Now we look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, they are opposite. It's negative, so we would have them be plus and minus. Factors of 2x squared, our first term, well, we know we'll have x and x. 2 and 1, where do we want to put the 2? Negative, positive, negative, 1 and 1. Because if this does work, we now have a what on top and bottom? X plus 1 and x plus 1, they match. Now we can check it to make sure. Because x times negative 1 would be negative x. 1 times 2x is plus 2x, which gives us a middle term of positive x, which is what we want. Now really at this point, we could say those simplify. Because anything divided by itself is 1. We have x plus 1 over x plus 1. Those cancel already. Where do we want to go to next? 2x squared plus 7x minus 15. And again, 2, 7, 15, no greatest common factor, and there's not one with variables. So we have our 2 sets of parentheses. Third term's negative, the signs are opposite. One's positive, one is negative. Factors of the first term, 2x squared. Well, we will have x and 1 and 2. Put the 2 with the negative. Factors of 15, our third term, are 1 and 15 or 3 and 5. 3 and 5, where do we want the 3 and 5? Put the 5 positive and the 3 negative. Well, if the 5's positive, we now have an x plus 5 on top and bottom. So that would be nice if it works this way, but again, if we remember back to one of the homework assignments, it did work out that nothing canceled. So it is sometimes good to check to make sure. X times negative 3 is negative 3x. 5 times 2x is plus, which gives us a, which is what we want. X plus 5 will cancel with. And that brings us to the last one. 4, 8, and 3 do not have a greatest common factor, so we don't pull anything out. Since the 3 is positive, our signs are the same and match the sign of the middle term. Negative and negative. Factors of 4x squared, we would want r 2x and 2x, yes. And 1 and 3 are the only factors of 3. And if we do check this to make sure, 2x times negative 3 is negative 6x. Negative 1 times 2x is negative 2x, which does indeed give us negative 8x. So it works out that everything's simplified, and we're left with. This problem specifically wasn't on the test, but a problem like it was on the test, yes? Except it was with division. Yeah, I think when y'all saw that, you overthought it just a little bit. And I've made this statement before, and I'll make it again. I think sometimes when I make the test easier, where you didn't have to factor anything for it, it sometimes makes the test harder. Because there's a fine line between making it too easy and just right. Because if I cross that line into too easy, I've almost crossed the line into too hard on some of them. But questions on this so far? Let's look at this one here. So again, when we multiply, the first thing we need to do is to factor. X squared is as simplified as it gets. It's a single term. There's nothing we can do to factor it. Now we just need to pick which one of the other 3 we want to factor first. X squared minus 4x. X squared minus 16. X squared minus 16 is a difference of perfect squares. There is no greatest common factor because we can look for it first. But x squared is x and x. 16 is 4 and 4, and we would have plus and minus. Is x squared minus 16 difference perfect squares? Those are nice. X plus 4x minus 4. X squared minus 4x. Well, it's not a difference of perfect squares. But we can factor out an x. Because x factored out of x squared is x. Minus, if I take an x out of 4x, we have 4. Our denominator, last one, x squared minus x minus 12. The negative 12 would give us plus and minus. Exactly factors of x squared are x and x. Yes. X minus 4x plus 3 because we need a negative middle term. So we would have x minus 4 and x plus 3. Now one thing I will say with this here, the numerators really don't help us determine which one we want, the 4 to be positive or negative. Because in the numerators we do have an x plus 4 and we do have an x minus 4. So it's not telling us one or the other. But this is the correct setup, and yes, one of the x minus 4s will cancel with one of the x minus 4s. What about the x squared and x? One of the ones on bottom will cancel with one on top, leaving us with in the denominator, in the bottom. Because we can say 2 minus 1 is 1. Bigger on bottom stays on bottom. And what else do we have left in the denominator? And on top we have x minus 4 times x plus 4. And that is it. Questions on any of this here? Do we feel comfortable with multiplication? We ready to because this one's here is not any different. It's going to be pretty much the same thing. If we feel comfortable with that, we'll move on to division, which, if we remember back to when we covered this first time, division is essentially multiplication. Up on the last one. And with any of these here, that's the first thing I would do. Before I do any factoring is we keep the first one the same, change it from division to multiplication, and flip the second term. Keep, change, flip. That's where I would start first before we start factoring. Now that we have it this way, and neither the numerator or the denominator will factor or simplify, we can multiply straight across. 7 times 3 is 21. X to the third. The denominator, we still have 5. Z times z to the third is z to the fourth. And that's it, because x and z won't simplify. They're not like terms. 21 over 5 won't reduce, so that's it. Questions on this here? Now this one here, it's very tempting to go on and start canceling things out. But again, the first thing I would do is change it from division to multiplication. So we keep the first one the same, x squared minus 9 over x plus 4. We change it from division to multiplication and flip the second. Now, if it's helpful to remember that these are each one term, x plus 4 is one term, x minus 3 is one term, and x plus 4 is one term, we can put parentheses around it just as a reminder to ourselves. Yes.
Shanna Ford, please go to Mrs. McClendon's room. Shanna Ford, go to Mrs. McClendon's room.
Now we still need to factor the x squared minus 9, which will factor to what? Yes, x minus 3 and x plus 3, because it's a difference of perfect squares. X squared is x and x, 9 is 3 and 3, and we have this here. Now really this is going to be 1, because we're kind of doing more things at once. This is gone, so the denominator is what? And these will, leaving us with x plus 3 over 1, or just x plus 3. Questions on this here? We ready for the next one? So with the x plus 3 squared, the denominator is understood to be 1. So the first thing I would do is keep the first the same, change it from division to multiplication, and flip the second. Now 1 and x squared are as factors as they get. The x plus 3 squared is as simplified as it gets. Now in the first one that we encountered having a square, because it was x, I think it was x plus 2 squared, we can write it as x plus 2 times x plus 2. There's nothing wrong with that. Or like in this one here, I can leave it as x plus 3 squared. Or we can say x plus 3 times x plus 3. Either way works. Now the numerator, x squared plus 8x plus 15, no greatest common factor. Since the 15 is positive, the signs are the same and match the sign of the middle term, which is positive. We have plus and plus. Factors of x squared are x and x. Factors of 15 that we want are 3 and 5, 5 and 3. And here it really doesn't matter since both signs are positive, both x's are just x. Putting it as 5 and 3 or 3 and 5, we'll get the same thing. Questions on this here? Now we do see that we have an x plus 3 in top and bottom, yes? It is very tempting to go here and here, but this is not true because the denominator has how many x plus 3s? 2 of them, yes? how many do we have on top? So what I do, if I don't write it out as x plus 3 times x plus 3, I just rewrite over the exponent. So here I write it as a 1, or I scribble it out and write it as a 1, and do that there. Now, I'm going to change it just for a second. Because if we said this was a 3, I can mark it out and make it into a 2. Because we're only removing one of them. So if there were 3 of them, and we take one away, there now 2. But that's not what we had. We had 2, but now there are 1. So that means the denominator is x squared times x plus 3 to the first, or we can just say x plus 3. The numerator is 1 times x plus 5, which is just x plus 5. Questions on this here? I don't think we have too many more division problems before we get into complex. So let's look at this one here. So again, the first thing I would do is keep the first one the same, change it from division to multiplication, and flip the second. Yep, you just put it right there. Thank you. Now, if we look at these here, so we changed it from, kept the first one, changed it from division to multiplication, and flipped the second. Now we can factor. And looking at these 4, well, 3x is as simplified as it gets. Which one do we want to work with next? 2x squared plus 4x. There's not 3 terms, but there is a greatest common factor of 2x. Because if we factor 2x out of 2x squared, we're left with x plus 2 factored out of 4 is 2, and the x factors out completely. So we get 2x times x plus 2. Do we want to look at the 12x squared one or the 3x squared one? Okay, so 12x squared minus 22x plus 8. Is there a greatest common factor? 2 will go into 12, 22, and 8. Is there anything else? Because 4 will go into 12, yes? Will 4 go into 22? No. So it's just 2. And if we divide everything by 2, we get 6x squared minus 11x plus 4. And 11 is a prime number, so yes, that was it. So that just means we're going to have to factor it most likely again. Now 3x squared minus, or 3x squared plus 2x minus 8. Since 8 is negative, our signs are opposite. One's positive, one's negative. Factors of the first term, factors of 3x squared. Well, we will have x and x, 3 and 1. Where do we want to put the 3? Negative. Factors of 8 are 1 and 8, and 2 and 4. 2 and 4. Where do we want to put the 2, and where do we want to put the 4? And lastly, we can check and make sure this works. X times negative 2 is negative 2x. 4 times 3x is plus 12x, which gives us a positive 10x. Is that the one we wanted? Okay. I'm just going to flip the 4 and 2. Make it 2 and 4. X times negative 4 is negative 4x. 2 times 3x is plus 6x, which gives us a positive 2x. Is that what we wanted? Yeah. Okay. Now there's one less thing to factor. We still have 3x, 2x plus 2, x plus 2 times 3x minus 4. Well, one thing we do know is that the x plus 2 and x plus 2 will cancel out. We could have canceled them in the last step because they are on top and bottom of each other. But the last thing we have to factor is the 6x squared minus 11x plus 4. No greatest common factor because we already took care of that. But since the 4 is positive, the signs are the same and match the sign of the middle term, which is negative and negative. Factors of 6x squared will have x and x. And factors of 6 are 1 and 6 or 2 and 4. Or not 2 and 4, 2 and 3. Which one do we want? Because what do we have down here? 3x minus 4, yes? So if one of these is going to cancel, we need to have a 2x and 3x. Specifically, we need the 3x. Now the factors of 4 are 1 and 4 or 2 and 2. Which 1 and 4, because if we do have 1 and 4, it does give me the ability to have a 3x minus 4 on top, yes? Now we can check and make sure. 2x times negative 4 is negative 8x. Negative 1 times 3x is negative 3x, which indeed is negative 11x. Which does tell us that the 3x minus 4 will cancel with 3x minus 4. Will anything else simplify? So let's go on and put them together and see. Because the numerator we have 2 times 2x is times 2x minus 1. And on bottom we just have 3x, yes? Will the 4 over 3 reduce? No. We still have the 4, we still have the 3. Will the x over x reduce? X divided by x is? So they cancel out, leaving us with, so 4 times 2x minus 1 all over 3 is our final answer. And that's it. Questions on any of this here? All right. How do we feel with division? You feel good with this here? Let's see where we're at. Do we need to see this one here? Do we feel comfortable with these here? Yeah. So we'll stop here. Because if we were to work this out, those are gone, those are gone. This here is what you should finish up with if we were to work this out. But this is where we're going to stop for today. We do not, because we still have complex that we want to get to tomorrow. So tomorrow we'll finish this up here. I will give you the worksheet now, and then you'll have some of the time in class to work on that tomorrow.